Good evening, sir. Okay, thank you so much, sir. A very good evening, everyone. I hope I'm
Good evening, ma'am.
good evening, Pooja ma'am. So, shall I start? Thank you so much, sir.
Yes.
Yes, thank you, sir. So, friends, today is day 2 of 7-day FDP, and today I'm going to discuss the reliability and the normality concept, right? So, I'll share my screen first. Give me a second, and then I'm expecting you to please confirm me whether what I'm sharing is visible to you people or not, right?
No, ma'am.
Okay, I shared my screen. Please tell me it is visible or not.
Yes, ma'am. It is visible, ma'am.
Fine, fine. Thank you so much, sir. So, friends, today, as I said, it's day 2, and the concept which I'm going to discuss today are the two concepts I'm discussing: the reliability and the normality. So, the agenda is firstly, we need to understand what is reliability, and then we'll see what are the methods of checking the reliability, right? Second thing is what is normality and what are the various ways and methods to check the normality of the data. So, in the first section, I'll discuss the concept of reliability and its methods. We will go to the SPSS, we'll check the reliability, and then we'll come back again on the slides and we'll discuss the next concept, normality and its methods. So, starting with the reliability concept, I divided the reliability concept into the 4 quadrants. Just a minute, friends. डॉक्टर को गई थी दिखाने हाँ तो sorry for the inconvenience. Okay, so I think again I am sharing my screen. Please confirm it is visible, I hope.
Yes, ma'am, it is visible.
Thank you. So as I said, I'll discuss the concept of reliability in the 4 different what I can say in the 4 quadrants I said. So the first quadrant is telling us what is reliability. So firstly, we need to understand the meaning of reliability. Reliability is nothing but it is a measure of consistency. Means if you are having any particular scale or questionnaire. So first thing is whenever we are talking about the reliability, we need to always have the scale. Scale meaning is questionnaire or the instrument, right? So when we are having the scale and it is generally measuring a single constraint, right? Say for example, I want to measure the satisfaction level, right? So I will be having all the questions which are helping me to measure the satisfaction of the person, right? So that way, if this kind of a scale I'm available, I can check whether that scale is consistent or not. That means if I'm telling this thing that the scale is consistent, meaning is very simple, that if I will conduct or if I will use the scale again and again, every time I will get the same results, right? That is known as consistency. So if your scale is consistent, you can declare this thing that your scale is a reliable scale. Next thing is when to measure the reliability. So the question is when the answer is when variables are on the Likert scale or on the non-Likert scale. Means in both the cases, whether the variables are on the Likert scale or maybe on the non-Likert scale. In both the cases, we can check the reliability of the scale. Next is where this reliability concept is applicable. So as I said, when we talk about our scale, that scale can be the existing scale or it can be the developed by our own selves, right? Existing skill meaning is that means if you are using the questionnaire or the scale of some other researchers, so that is known as existing skill. So in that case, again you need to check the reliability, means already it is tested skill, because if someone has already used a skill, that means it is a tested skill, right? But when we are using a tested skill, so question comes, why we are checking the reliability? So the answer is very simple. Might be possible that skill which was developed by the previous persons is there can be a difference of the time, means uh, at what time period they have developed, and now presently if you are using, so might be possible changes are there in the environment meaning is in a particular scenario the changes can be there. So that way might be possible you will not be able to get the same results. So again you need to test whether the scale is reliable or not, that means consistent or not, it is giving you the same results or not, right? So that is the one thing. If you are using the already available scale, in that case also you need to check the reliability of the scale, right? Second thing is when you are developing your own skill, that is self-structured skill. You have made your own questionnaire, right? So in that case also it is very imperative to check the reliability. So meaning is very simple. Either you are using the scale of others or you are developing your own skill. In both the cases, you need to check the reliability of the skill. Next comes how to measure the reliability. So to measure the reliability, we are having certain methods available with us. Using those methods, we can check the reliability of the scale. So I hope the concept of reliability is clear to everyone.
Ye-
This slide is clear, friends? Yes.
Ma'am, can you
Yes, ma'am.
please pardon the start again, ma'am?
Start again. Why?
I'm a bit confused with either using existing scale or self-structured scale.
So
That's
better you
all.
can ask me the questions. It will be better you can ask me the question. What is the confusion? I don't know. So repetition is not the correct way. If you can ask me what problem or what confusion you are having, what doubts you are having, you can ask me, ma'am.
Ma'am, that point I'm not getting. Either using existing scale or self-structured scale.
Sorry.
Ma'am, that point, either using existing scale or self-structured scale. This is not clear to
So
me,
I
ma'am.
think I said this thing. If you are using the existing scale, means if you are using the scale of some other persons. So I think it is quite obvious. Sometimes when we are referring the research papers and we are finding some construct which is already tested by the other people. So the questionnaire is available to you. So if you are using the other person's questionnaire for collecting your data, even in that case also you need to check the reliability. One thing. Second thing is if you are developing your own questionnaire, own scale, in that case also you need to check the reliability. Is it clear?
Okay, ma'am.
Yeah. Now next comes the types of reliability. So there are two types of reliability: stability reliability and the internal consistency reliability. Stability reliability meaning is what? Stability reliability means your scale is consistent, your scale is producing the same results again and again. Second thing is internal consistency reliability. Meaning is that if you, as I said, if you are having a questionnaire or a scale which is measuring a particular thing, say for example, if you have heard about there is a model named as ServQual, SERVQUAL, ServQual model. That is service quality model, right? So if you have used it, or maybe if you have heard it, and if you have seen this particular questionnaire or the scale, in that there are 5 dimensions, right? And for each and every dimension, there are a certain number of items. So that means all the items, 22, 23 items, all total items together, helping you to measure the service quality, right? So if you are having such kind of a scale, so the items which you are taking, that is questions which you are taking on a scale, they should be internally consistent. They should be internally linked with each other, right? So that is a second type of reliability. So again, I'm repeating, there are two types of reliability: stability and the internal consistency. Stability meaning is what? Your skill is stable and able to produce the same results again and again. Internal consistency reliability is what? In with this case, you will be having certain number of items, and all the items will helping you out to measure a single thing, right? So all the items or the questions should be interlinked, should be related to each other. that is known as internal consistency reliability. Further, there are various methods available to check the reliability, named as test-retest reliability, parallel form reliability, split half reliability, and internal consistency reliability. Out of these four,
Excuse me, ma'am.
first, yes,
Ma'am, slides are not moving, ma'am.
oh, sorry, it is for everyone.
Yes, ma'am.
Fine. Yes. Again, I'm sharing. Please wait. Now tell me, these slides visible now?
Yes,
Yes,
ma'am.
ma'am. Now it's visible.
Yes. So again, I'm repeating here. I was talking about various methods which can help us to measure or check the reliability of the scale. So these are four methods: test-retest reliability, parallel form reliability, split half reliability, and internal consistency reliability. Out of four, first two comes under the stability reliability. That means if you want to test whether your scale is stable or not, you can use test-retest reliability or you can use parallel form reliability. One more method is to check the reliability is split half reliability, and next one is the internal consistency reliability. So these are the four methods. So now from the next slide, I'll explain you all four one by one, right? So now I'm moving to the next, that is test-retest reliability. So here you can see all the theoretical background of test-retest reliability. I tried to kept here in a slide. But to reduce means to make it more easier to understand test-retest reliability, I developed a diagram here. So this is a diagram which you will not find anywhere else because this is made by me only by understanding the concept of test-retest reliability. So in this case, if you will see the diagram, what you can see, suppose firstly we are having a test. Test meaning is the questionnaire or the instrument or the scale. So again, I'm repeating, do not misunderstand this point. Test meaning is what? Your questionnaire, right? Your scale. So what you need to do, whatever scale you are having, you will circulate, you will give that scale to a group of people, a group of respondents, right? Suppose you are having a scale, it is having certain number of questions, and you are giving this scale to suppose 100 people, right? So those 100 people will give you the responses and you will collect their responses, right? Then after 6 months, means there will be a sufficient time gap, and then again you will conduct this scale and you will give this scale to again same group of people. So whatever, suppose 100 people were there, same 100 people will should be available at the second conduct also, but there should be the sufficient time gap, right? And then again you will give the same scale to them and they will give you their responses. So that way you will collect their scores, their responses, right? And then in the both the responses in both the square scores, you will calculate the coefficient of correlation, right? And if coefficient of correlation comes greater than zero point 0.7, means 0.7 or above it, in that case you can declare your scale is stable scale, your scale is reliable scale according to the test-retest reliability, right? So this is the first way of testing the reliability of your scale. I hope it is clear, friends.
Yes, ma'am.
Yes.
Yes, ma'am.
Next, yes, thank you. Next comes parallel forms reliability. So again, to make you clear this thing, I tried to convert this theoretical background in the form of diagram. And then again, I'm repeating this, that what is parallel form reliability using this particular diagram. You can check here what we will be having. We will be this means this particular diagram is starting from here, right? Where we are having a test. Test meaning is scale or the instrument, right? So we will be having a scale or questionnaire available to us. We will divide that into the two parts. Suppose I'm having 30 questions. So I will keep first 15 into the first part, next 15 into the second part. Or maybe all odd number questions in the first part, all even number questions in the second part, up to us, right? That way we can do the division of the questionnaire. And then to a group of people, you will give the part number one, first part. First 15 questions you are giving to the some number of people, right? Then there will be a some small time period gap, right? And then to the same people you will give the second part of your questionnaire, and that way you will collect their scores. And then in these scores we need to find coefficient of correlation, and if the coefficient of correlation value is zero point 0.7 or above it, you can say your scale is a reliable scale, right? So this is the second method known as parallel form reliability. I hope it is clear.
Yes, madam.
Yeah. Next comes split half reliability. So again, I tried to make a diagram for you for split half reliability. Here you can check. This time, rather than dividing your test, what we will do, we will take two groups of these respondents, group number 1, group number 2. And at the same time, we will provide the scale or the test to the both groups parallelly, right? And then we will collect their scores. And after collecting the scores of group 1 and group 2, we can find the coefficient of correlation between them. And again, as a threshold value, that is 0 0.7 and above. If this correlation value is 0 0.7 or above, you can declare that your scale is a reliable scale according to the split half reliability. Is it clear to everyone?
Yes, ma'am.
Fine. So this way, this was the third method of testing the reliability. Next one is the internal consistency reliability. Internal consistency reliability meaning is here you need to see the degree of homogeneity in your items, right? Means whether the items, that is questions. So please be careful, items and questions one in the same thing, right? So whatever number of items we are having, you need to check whether the items or the questions are homogeneous for a particular scale or not. So this type of thing, homogeneity in the items, we can check using the internal consistency reliability, right? So you need to check this thing up to what extent your items or questions are internally consistent with each other, right? So again, correlation will be the base here for checking the internal consistency, right? So threshold is generally 0 0.7 and above for internal consistency also. Here, to make you more clear about this internal consistency, one example is here, that is, if suppose we want to measure the motivation of a person, right? So we know this thing, motivation of a person cannot be measured using any apparatus, or there is no unit also available for measuring the motivation. So for the purpose, suppose 10 items were taken. 10 items means 10 questions, indicators, dimension, etc. You can say. So suppose we have taken total 10 items to measure the motivation, right? So here motivation will be your construct or your latent variable, which is hidden. Directly you cannot measure it. To explore the degree of motivation, maybe we can ask certain number of questions, right? So if all these questions or all these items are internally correlated, in that case, you can call that your scale is internally consistent scale, right? So there should be a fair degree of correlation between the items of a particular scale. In that case, you can declare that your scale is a reliable scale or not. Is it clear?
Yes, ma'am.
Fine. Now, to measure internal consistency, reliability, right? That means up to what
Excuse me, ma'am. What is the homogeneity? How can we check homogeneity?
homogeneity means humanness, similarity. So if two variables are very, very similar to each other, so in that case, you can find portion value will be a very good value, strong value, right? Is it clear?
Okay, ma'am. Okay.
Yeah. So to measure internal consistency, there is a measure comes named as Cronbach's alpha. So Cronbach's alpha is a very popular, very famous method. Using that, we can check the internal consistency. And presently, when we talk about factor analysis and above other methods like this, generally we are testing the convex alpha or internal consistency using the convex alpha, right? So this is a reliability coefficient which is generally named by the or after the name of the American psychologist Lee Cronbach. So Mr. Lee Cronbach in the year 1951 introduced this particular convex alpha, and after his name we can call, or we are calling this particular measure as a convex alpha, right? So this is helping you to measure internal consistency or internal inter-item reliability, right? So now if we are applying the convex alpha, so whether you are having the dichotomous scale items or maybe you are having the Likert scale questions, right? For any questions you can apply the convex alpha, right? But provided this, that all the items of a scale which should be on a same scale, either on a, all the items should be either on a Likert scale or maybe on a dichotomous scale or maybe continuous in nature. So this is we need to be careful while applying the convex alpha. Next comes the, if we are going for the manual calculations, right, for getting the convex alpha. So there are two formulae. First formula is based on the variance method and second one is based on the correlation method, right? Usually as we are using a software, so we do not need to see that how we need to work on the formula and what are the different what I can say indication of these different notations. We do not need to see all these things, but I need to tell you one thing. There are two methods. One is based on the variance. Second one is based on the correlation. So generally when we are talking about SPSS, we are testing on the basis of correlation method. Now the next important thing is interpretation of convex alpha. So I will read this particular table from the bottom. I'll go from bottom to up or top, right? So here, if your alpha value of convex alpha less than 0.5, that means it is indicating or it is an indication of unacceptable reliability of your scale. If alpha ranges in between 0.5 to 0.6, it is known as poor reliability. Between 0.6 to 0.7, it's questionable reliability. Between 0.7 to 0.8, acceptable reliability. 0.8 to 0.9, it is good reliability. Above 0.9, if alpha comes greater than 0.9, it is known as excellent reliability. But there is a problem if your alpha is greater than 0.9. This is also the indication of multicollinearity. What is multicollinearity? Multicollinearity meaning is that your items are almost identical, almost similar, right? So it is quite obvious two questions or two items should not be similar. In that way, if they are similar, so it is quite obvious you can put only one of them, right? Or maybe if items are having Cronbach alpha value or maybe quotient value greater than 0.9, that means the respondents are taking your items as very similar. So they are responding in a same fashion. So that is why you need to check if there is a problem of multicollinearity on your scale, and if some two or three items are very closely related, correlated to each other. In that case, you need to decide upon which item you are going to keep in your scale and which you are dropping, right? So multicollinearity is nothing but it is a very much similar items you are having on a particular scale. Then comes how to check convex alpha. So I think I'm not reading this particular slide. This I'll show you how we can check the reliability of the scale. Next is acceptable range of the convex alpha. I already told you should be in between 0.7 to 0.9. Then sometimes it happens that when we are testing the reliability of a scale, might be possible it is not coming up to the mark. And still, if we want to go for further, we want to proceed further. In that case, question comes: can we improve the reliability? So the answer is yes. We can improve the convex alpha. How? The first thing is you need to remove ambiguous and the redundant items. You need to check whether any particular item is double meaning question or not. Means your question should be very simply worded, simply stated, and it should not be having any double meaning. So that way, this precaution you need to see while making your questionnaire. You need to check if two items are repeating or more than one item is repeating in your scale, in your questionnaire. You need to drop all the remaining items. You need to keep only one question. So there should be uniqueness, right? So that way you need to check this thing, observing, you need to do by observation or by reading or by meeting the expert of a field, you can check this particular thing. And if you are able to do so, if anything is like that available in your questionnaire, that means it is making problem in the Cronbach alpha value. So if you can talk to the experts of the field or the senior person, they can help you out to make your skill better. Next comes diagnose missing value. So if suppose you are having a missing value, right? For example, there are three items or three questions available. In that, we have observed that there are certain missing values. So in that case, if missing values are available, it is also creating problem in the improvement of the Cronbach alpha. So if missing values are there, you need to deal or you need to deal with them, right? And that way it can help you to improve your Cronbach alpha. Next comes diagnose item total correlation. So this particular thing you are getting in the output of reliability only, right? There is a particular column dedicated for this particular measure named as item total correlation. So you need to carefully look at this particular column and you need to find this thing. If any of the item total correlation is negative, so first check is you need to check if any of the item total correlation is negative, you will immediately delete that item from your scale, right? You will drop that particular variable, you will drop that particular question from your scale, and then again you can check the Cronbach alpha value. If it is helping you to improve, it is good. And still if you are finding it is not coming according to your threshold value, in that case next check is you need to check now next which one is the very least value in the item total correlation. If it is negative, I think we have dropped them, but now if all the item total correlation are positive, you need to check the least or the very small value in the this particular column. So if for any item this value is coming very small, you can drop that item. Again, you can perform Cronbach alpha process, and then you can check whether it is improving your Cronbach alpha or not. So this way, generally, first thing is negative item total correlation should not be there. Second thing, if item total correlation is very small, less than 0.2 or equals to 0.2 or all, in that case also you can take a call to drop that particular item, and it can help you to improve your Cronbach alpha value, right? So this way, these are the three methods of improving Cronbach alpha. I'll repeat again. First one, you need to check whether your items are ambiguous in nature or not. You need to check any redundancy is there in the items or not. So these two check you can do using or by reading your questionnaire, or you can meet to the experts or seniors of that particular domain, and they can help you out. Second thing is you need to check whether the missing values are available in your scale or not. If missing values are available, you need to drop those items, or maybe you can impute missing values by these generally average and all. So that can help you to improve your Cronbach alpha. Last thing is you need to check the item total correlation column. If any of the item total correlation is negative, so you can immediately delete that particular item from your scale, and this can help you to improve your Cronbach alpha value. Second check is if suppose all the item total correlation is positive, in that case you can find the least value in the item total correlation. You will drop that particular item, and then again you can check whether it is helping you to improve your Cronbach alpha or not. So these are the three ways of improving the Cronbach alpha. I hope it is clear to everyone.
Am I audible?
Yes.
Yes, ma'am. Good evening. I'm Dr. Savita. Thank you for your presentation. Ma'am, I had one doubt. So this was basically regarding my study, and it is a like personal doubt from the questionnaire. So in case of ma'am questions like yes, no, and maybe, so how is the scoring, ma'am? For example, it's a bit of confusion. Some people say that for yes, it will be 1, no and maybe will be 0, 0. Some say maybe will be -1. So my first question is that how will be the scoring in such cases? Second is, will we be able to get the video recordings of this later, madam, of the presentations? So these are the two questions. Thank you.
Okay. Generally, ma'am, as you are saying, if there are three options available, yes, no, and maybe, so you can keep no as 0, maybe as 1, and yes as 2. Generally, these are the categorical skill questions, right? Categorical skill questions are meaning is you are generally categorizing how many of the people are saying yes, how many of them are saying no, and how many of them are saying maybe. As there is no, what I can say, we can also we can say this is an ordinal scale question. Categorical, in categorical it is ordinal scale, right? So no, then higher level is maybe, and the higher level is yes. Getting my point? So generally, if we are giving any coding to these categories, it is only the representation. So number is not playing any role there.
Okay.
It is only for the identification purpose we are giving these numbers. So there is no role of 1 0 1 and 2, or maybe 0 minus 1 0 and 1. There is no role of these, because this is only for the representation purpose, for the identification purpose we are giving them. Getting my point?
Yes, ma'am. But one more thing, when we go for the standardization of the questionnaire, will it affect, or in such questions, like you said, reliability and all
I
that?
think why you need to go for this standardization? For categorical variable, there is no need of standardization.
Yes, ma'am. That was also my doubt, because some say that the standardization required, some say it's not required. So,
But depending which kind of test you are performing further on your questionnaire or on this particular question, if this is you are treating as a categorical data, for categorical data, there is no need of standardization, because we know this thing. Because in the second half of the presentation, I'm going to talk about the normality, right? So normality is generally we are testing for the continuous variable. For a non-continuous variable, there is no need to check the normality. As you have heard about non-parametric tests, these are based on the categorical data, and non-parametric tests are not bothering about the normality of the variable, because these tests are dealing with the categorical data. So there is no need to test the or make them standardized.
oh, okay. Thank you, ma'am.
Yeah. And second question is, already I think Yogi sir has shared in the group all 7 days YouTube links, right? If you wish, you can check out the WhatsApp group. If not, you can request in a group. So sir will share. So all the link is developed by the or created by the RFI. So they will share you the links.
Okay. Thank you so
Madam,
much, ma'am.
I have one more doubt, madam. Madam,
Yeah.
in my case, I have 5 categories, madam. For example, I'm doing analysis based on the discomforts. So in that, I have 5 categories. In each 5 categories, I have subcategories, madam. For example, good, severe, moderate, like that, madam. At that time, what kind of approach test I can adopt for it?
Sir, I think I cannot comment like this on this particular thing, because always when we are talking about performing of the test, it is totally depending upon the objective of your study. I think yesterday when I talked about the components of the research paper, I told this thing. There is a sequence. Generally, we are raising questions. Questions can help you to write your objectives. Objectives can help you to write your hypothesis. And using your hypothesis, you are deciding which test is applicable. So it is depending upon which hypothesis you have created in your research. Accordingly,
Yes.
you can decide. So you need
At
to,
this time, what kind of analysis technique I can adopt?
again I repeat, I cannot comment on that, because I don't know what kind of interest you are having in your variables. Whether
Yes.
you are, means firstly you need to decide upon whether your means two things you need to answer while testing any hypothesis. First thing, how many variables are available in your hypothesis. Second thing is, what is the type of your variables, right? And third thing is that whatever variables are available in your hypothesis, what type of relationship you want to find them, right? So
Okay.
generally, t-test, ANOVA we are using for finding the significant mean difference, right?
Okay, madam.
Similarly, talking about the relationship, we can go for the correlation. If we want to see the impact, means how much one variable is making change in the other variable. If this kind of a study you want to do, you can go for the regression. If you want to find the association between the categorical variable, you can go for the chi-square test. So depending upon your study, what kind of hypothesis you have developed, which variables you're taking in your hypothesis, that can help you to decide upon which test you are going to apply. So I think we are having remaining 5 days where I'm talking about the tests, right? So as
Yes,
we will proceed, I think that way maybe you can get answer. If not, you can discuss later on also in the
okay,
upcoming
thank you.
session.
Thank you. Thank you.
Fine. So I hope it is fine. May I proceed? Any other doubt? Yes. Please confirm me. No doubt. Shall I proceed with the next thing?
Ma'am.
Yes, ma'am, you may proceed.
Yeah, thank you so much, ma'am. So, friends, now what you need to do, I have provided you this sheet with the name Customer Satisfaction Towards Restaurants. I hope you have found that. Those who are having the SPSS, only they can open this file because it is .sav file. It will be only opening in the SPSS, right? So open the file. I hope you have opened, everyone. Everyone, have you opened? Shall I start explaining you now? Please confirm. Yes, please confirm. Friends, shall I proceed?
Yes, ma'am.
Yeah.
Yes, ma'am.
Fine. Thank you so much, ma'am. You can see the sheet which I provided you. I'm going in a variable view of this. And that way you can see total 31 items or total 31 questions are listed here, right? Then you can check their labeling is also given, right? So that way you can find we are having 31 numeric questions with the labels, and all these questions are on the 5-point Likert scale. You can check. Click on this and you can check. 1 is for the strongly disagree, 2 is for the disagree, 3 is for the neutral, 4 is for the agree, and 5 is for the strongly agree. So here, using these 31 items or using these 31 questions, our interest is to measure the customer satisfaction, right? Means all the questions are linked with the restaurants. So services of restaurants, right? And then we want to see what is the person's expression, whether they are satisfied with all these amenities available in the restaurants or not. So that way we are having total 31 questions for measuring the customer satisfaction towards restaurants. Is it clear?
Yes.
Fine. Now, how to perform reliability? We need to go to the analyze. Done. Go to the scale and then select reliability analysis. So I'm giving you few seconds. You please check what I did. I said you need to go to the analyze tab or analyze menu. Then a drop down will come on. Then all the prompt will appear with all the tests available. From there you need to select the scale, and from the side arrow you need to select the next prompt. From there you need to select the reliability analysis. If you have found, please tell me so that I can proceed further.
Yes, ma'am.
Okay. Click on this. Now, I am using my keyboard and doing Control A. So all the listed items or questions or available items and questions on my scale is listed at the left box. You need to select all of them and shift them into the items box using the arrow key. Done.
Ma'am, one question from my side, ma'am. How can find out this type of sheet in my SPSS, ma'am?
Means?
Ma'am, how can find out this type of sheet in my SPSS?
I think this is the sheet given by me to you people, sir. This is the data collected by my students.
But through the hands-on practice, how can identify? Actually, I want to hands-on practice on this type of data through my SPSS, ma'am.
So if you have downloaded it and
Yes, ma'am. Already I have downloaded the
Yes.
SPSS module.
So
ma'am.
you can go to that particular folder. There will be a sample folder available that will give you sample files. Fine. So after shifting them into the right box, click on the statistics tab or button. And in this particular dialog box, at the left hand side, extreme left hand side upper side, you can find there is a section available named as descriptors for. So you need to select all the 3 check boxes. Done? Yes, please confirm. Done? Friends, say something.
Yes, ma'am.
Click on continue and then OK. So you would be landed on the output viewer, which is storing your output. So there are 2 windows. One is the data editor, which is showing you the data view and the variable view. And second one is the output viewer, which will show you the output, whatever you have performed. Done? I hope everyone has got it. May I start explaining this? Yes?
Yes.
Fine. You can check at the first, we are getting a case processing summary table, which is indicating you total 121 observations we are having, right? Nothing is excluded, no missing value is there. Next comes the reliability statistics, which is showing you the Cronbach's alpha value, which is 0.672 for the 31 items. For total 31 items, the Cronbach alpha value is 0.672, which is not acceptable value. It is less than 0.7, right? So now we need to check whether we can improve it or not. So for that, firstly, I'll go to the next section or next table, which is the item statistics. There you can find all the 31 items are listed along with their mean, standard deviation, and the number of observations. So for the first item, which was related to the modern equipment in the restaurants, right? We can find the mean is coming as 1.49. So as I said, this is a Likert scale question. On a 5-point Likert scale, the mean value is coming as 1.49, which is in between 1 and 2, right? And 1 was strongly disagree and 2 was disagree. Somewhere people are disagreeing with this thing that restaurants are having modern equipments. Is it clear? I hope
Yes.
it's
Yes, ma'am.
fine. Next is the physical facility. So this is more than 3. 3 is for the neutral, and when we are moving from 3 to 4, it is agree, right? Now people are agreeing that the restaurants are having physical facilities, right? So likewise, you can read these figures for the remaining items, right? Next one is the standard deviation. Generally, this standard deviation should always be less than your mean value. So we can compare for each and every item mean value, whether this standard deviation is lower than that or not. So this way, this is the first, after reliability, this is the first table I discussed. Next table you can see, which is item total statistics. Now please listen carefully. In this particular table, all the items are listed firstly, and then next comes scale mean if item deleted. Means if suppose you will delete the first item named as modern equipment, if you are deleting that, in that case the scale mean is for the remaining 30 items, the mean value will come as 96.74. Similarly, if you are relating this item, so the variance will come to the 147.242. So this is the meaning of column number 1 and column number 2. Next comes, I think before reading the third, I'll come to the fourth column. There you can find Cronbach's alpha if item deleted. If you are deleting the item number 1 from your scale, your Cronbach alpha will reach to the 0.675. Presently, it is 0.672. You can check it is 0.672. But if you are dropping your first item, it will little improve. It will improve it, and its value will be 0.675. So that way, for the entire items, you can check. If you are dropping any of the items, it is not taking you anywhere till 7. If it is 0.7, it is okay. But I think for any of the items, if you are dropping, it is not helping you to improve it. So the next check is what? Now you need to check for the third column, which is corrected item total correlation. There you can check. Firstly, I said you need to firstly check for any of the items whether this is coming negative or not. You can go down. You can check I think you can see here there are two values, minus 0.110 and minus 0.102 for the attentive attitude and for the personalized service. For these two items, the item total correlation is negative. So this is the first check we have applied. So let's try. We are dropping these two items first, and we see whether there is any improvement in the convex alpha or not. I hope till here I am clear to everyone.
Yes, ma'am.
Fine. To go to the analyze, then scale, and then reliability analysis. So click on this. I hope I can click.
Yes.
Fine. Now you need to find attentive attitude, which is this, and personalized service. Right? So I'm selecting both the two items and shifting them back in the previous box using the arrow key. So now I'm having only 29 items. Done, everyone?
Yes, ma'am.
Now click on the OK button. Now one more thing you can check, model value. I think previously I told you, forgot to tell you this. By default, this is taking alpha, that is convex alpha. There are some more, split half, Gutman parallel, and strict parallel. So I think we are interested in checking the internal consistency. So we'll go with the by default option. Now click on OK. So once you are doing okay, I think you can check now the reliability statistics coming as 0.701 for the 29 items, because we have dropped 2 items out of 31. So remaining items are 29. For these 29 items, convex alpha coming as 0.701, which is acceptable value, right? Is it clear to everyone?
Yes, ma'am.
Now, if still you want to little more improve this, you can go down and you can check for the remaining items. For the remaining items, your convex item total correlation is still negative or not. So I think you can cross check. For no item now, convex item total correlation value is negative, right? But still, if you want to take a call, you can check the very small figure here, I think, which is this 0.009 for on-time serving, right? So that way, if this will be totally the call of the researcher, up to what extent you want to drop the items to improve your reliability coefficient, right? But you need to be very careful also, because if you are dropping so many items from your skill, so again you will be answerable that why you have dropped these number of items. So you need to see up to what extent you can drop them. That will be totally the call of researcher. Nowhere this kind of things is mentioned that how many items you can drop, right? If you are dropping, you need to justify why you have dropped the items. Is it clear to everyone?
Yes.
Fine. So this way we have checked reliability and we have tried to make the improvement in the reliability by using the one of the methods I told you to improve it. Done? Done?
Yes.
Now, next, I think if it is done, I'll go for the next section of the presentation, which is related to the normality. So may I go for the normality?
Yes, ma'am. Yes, ma'am.
Fine. So I think I am again sharing my slides. I hope my slides are visible to every one of you.
Yes, ma'am.
Yes, ma'am.
Thank you so much, ma'am. Now I'll start with the concept of normality. So you need to be very much clear here. When we talk about reliability testing, we are testing the reliability of the scale. Scale means number of items, number of questions, right? When we talk about the reliability, here we are checking the reliability of a variable. Variable means of any particular item, right? Or question. So, firstly, you need to understand the concept of normality. Normality is the thing, but we want to see there is a distributions. If you have heard about normal distribution, binomial, Poisson, gamma, so many distributions are there, right? So one of them is the continuous probability distribution, which is known as normal probability distribution. So in this case, we want to see whether the distribution of the values of the variable is normal or not. Means you want to make a histogram or maybe a bell-shaped representation of your data. So that way, if your data points are coming under the bell-shaped curve properly, you can declare your data is normally distributed. But it is not like that each one of us or everyone is very comfortable doing the interpretation using the graphs. So that is why there are certain characteristics or features available of the normal distribution. One of them is mean should be 0 and standard deviation should be 1 of your data. This is the first thing, right? But usually, sometimes it is not possible. If suppose we are talking about the Likert scale question, right? So on a Likert scale, generally we are giving the values as 1, 2, 3, 4, 5. So anyway, it is not possible to come as 0. Mean will not be 0 in such case. Getting my point? So you need to be means we need to have some other observation or other parameters also. So usually it is said that when mean, median, and mode, all three are equal. This is the one characteristics. Means one more characteristics of the normal distribution. Mean, median, and mode should be equal. Second thing, skewness should be 0. Next is the kurtosis should be 3. Then standard deviation should be 1. So these are the sum of the parameters of normal distribution. Using that, somewhere we can decide or we can what I say comment on the normality of the variable, right? So that way, when you are talking about the normality assumption of any variable, you are generally testing or calculating the descriptive statistics of your data. Looking at that descriptive statistics, you can comment whether your variable is normally distributed or not. Or maybe you can go for the graphical representation of your data, and that way you can decide whether the variable is normally distributed or not. So to ascertain normality of any variable, the two important parameters are skewness and kurtosis. Skewness is the measure of asymmetry in the data, right? If you have seen bell-shaped curve, I think I'm showing you a slide where you can find the middle graph, which is there. This is the normally distributed graph, right? If you will look at this, you can see generally, as I said, at the middle, mean, median, and mode are equal. So this is the point where you can call your mean, median, and mode are equal. And when I say skewness is a measure of asymmetry. That means whether your data is symmetrical to mean or not. Meaning is from the mean. If suppose mean is lying at the middle, so 50% observation should go at the right hand side of the mean, 50% observation should go at the left hand side of mean. That means there is a symmetry, 50% here, 50% here. But if this proportion changes, that means your data is not symmetrical. In that case, it can be either the negatively skewed data or it can be either the positively skewed data, right? In case of negatively skewed data, your mean value will be less than to the median, mean will be less than to the mode. That means mode will be the highest value in case of negatively skewed data. Whereas in case of positively skewed, your mean will be greater than to the median and median will be greater than to the mode. That means your mean value will be highest in case of positively skewed data. This is the this is about the skewness. Next comes is the kurtosis. Kurtosis can help you to understand the sharpness of your bell-shaped curve. If your bell-shaped curve or maybe if the data is having the kurtosis value as 3, that means your data is known as mesokurtic data, right? But when it is less than 3, your data is known as platykurtic, and in that case your bell-shaped curve will be flatter, right? But when the kurtosis value is greater than 3, so there will be your bell-shaped curve bell will be very sharp. Your sharpness of your curve will be very, very, what I can say, narrow. This curve will be very narrow. In that case, this type of data is known as leptokurtic data. So looking at the bell-shaped curve, you can comment whether your data is normally distributed or not, right? So this is the concept of normality. So using the mean, standard deviation, skewness, and kurtosis, we can declare whether the data is normally distributed or not. If you are very narrow, you can take the kurtosis values plus minus 2 also, right? and if not, you can go for the plus minus 3. Is it clear?
Yes.
Yes, ma'am.
Right. Thank you. Now we will see what are the methods of checking the normality. So I divided this into the two parts, numerical methods and the graphical methods. Under the numerical methods, we can keep skewness and kurtosis indicators. Apart from that, there is a test named as Kolmogorov-Smirnov test, or you can use Shapiro-Wilks test. So these are the two tests. Using that also we can check the normality of the variable. Under the graphical method, we can keep histogram, QQ plot, and the box plot, right? So using these representation of the data by these particular graphs and charts, we can also ascertain normality of the data. If I talk about histogram, I don't think so. No one has seen histogram. Everyone of us has maybe seen or maybe made also the histogram. Histogram is very similar to the bar graph, right? But when we talk about bar graph is having the gaps in the bars. But in the histogram, there is no gap in the bars. Reason is we are dealing with the continuous variable, right? So when you are talking about the normality, you are testing the normality of a continuous or numeric variable and not the categorical variable, right? So you need to make the histogram. Using the histogram, नहीं निकला कुछ, सिर्फ avoid है. 1 minute, friends. Hello, I'm audible.
Yes, ma'am.
Yes, ma'am.
Extremely sorry. Actually, I'm in a college. Yeah. I'm again starting with the histogram. I have said when we talk about histogram is very similar to bar graph. In the bar graph, if you have seen, there are gaps in the bars. But in case of histogram, there is no gap. Reason is very simple, because we are dealing with a continuous variable in case of histogram, right? So in that case, there should be no gap. There will be continuity in the bars, right? And when we talk about the histogram, it is indicating you the frequency distribution, right? For a particular, means suppose there is, you have made a, your scale x-axis is 0 to 5, 5 to 10, 10 to 15, likewise. So in between 0 to 5, what is the count? So that is a frequency distribution histogram. And then we are having softwares, as we are using SPSS today. I'll say, show you that how you can keep the bell-shaped curve on a histogram. And that way, using that bell-shaped curve, we can ascertain whether the data is normally distributed or not, right? So looking at the variety of histograms, so there can be means there are various possibility of the histogram diagram. You can check at the left side upper, you can find this particular graph. This is indicating this is not normally distributed. If you will keep, means you can visualize this thing, you can imagine this thing. If you are keeping a bell-shaped curve on this particular histogram, it will be positively skewed. Positively skewed means your right tail will be larger than to your left tail, right? Similarly, this side, if you will come, you can find this is the double peaked graph, and that way you can find there are two modes. If the two, what I can say, two peak you can find, that is a double or the double peaked graph. That means there will be two modes, right? At the bottom, if I'm coming left side, you can see again it is a clear indication. It is the right skewed kind of graph. And here, if at the right hand side, lower side, you will come. This is indicating there is no proper shape. At the middle, if you are coming, it is indicating you that the so this is indicating your data is normally distributed. Medicine. So this is the middle one is indicating you your graph is normally distributed, right? Sorry, your data is normally distributed. Next is again one more indication of the histogram. Here you can see this first graph, left hand side graph. If you will see, there you can find if this is what I can say narrow. Narrow meaning is there is very less spread. Means the standard deviation is less in this particular graph. But when we talk about the right hand side graph or histogram, you can find there is the this graph is this bell curve is very wide. Meaning is that the standard deviation value is high in this particular case, right? So this is a way of checking the histogram and commenting on the normality of your data. Next method, graphical, is QQ plot. QQ plot is quantile plot, right? So in that case, you can find there is a solid line. And if all the data points are following your solid line, that means it is normally distributed. But when there is a deviation from the line, so you can find there is a deviation. So in that case, if you are able to see a curve at the right side of the line, that is indicating your data is left skewed, right? If this curve is coming at the upper side of the line, that is indication of the right skewed data, right? Then talking about the tails, leptokurtic data, meaning is your tails will be very thick. Thick meaning is so many data points are falling on the tails of your data, of your graph, right? So this is the indication your QQ plot will be like this. That means your data is leptokurtic data. Apart from that, thin tails meaning is there will be less number of data points which are falling on the tails. So this is the indication of the platykurtic graph or platykurtic data using the QQ plot. Box plot is again a very imperative chart or plot in case of the normal distribution. Apart from understanding the normality, you can also check the outliers in your data looking at the box plot. So there are 5 components of box plot. The middle one is the median value, right? So if you have plotted your graph or box plot for your data, so the middle line of the box plot will indicate you that this will be the median value. The upper wall of the box will be the third quartile. The lower, what I can say, border of the graph of the box is known as the first quartile. above third quartile, this area is known as the upper whisker. Lower means the lower the first quartile area is known as the lower whisker, right? And beyond these whiskers, if any data points are falling, generally it is indication of the circle or asterisk. So if any data points is coming as a circle or asterisk, that means this is the outlier available in your data, right? So box plot is very useful. This can help you for understanding the normality also, and most important, it can help you to understand the outliers in your data, because outlier can be the thing which can impact your results, right? So that you can test or check using the box plot. So this is about the, I think, theoretical background of the normal distribution or normality of the data. I hope it is clear to each one of you. Any doubt? Anyone?
Yes, ma'am.
Okay, no doubt, I hope. Yes is for no, right?
Yes, ma'am.
Fine. So I think if it is okay, I'm expecting you to open the second sheet given by me, named as the bank loan, I hope. Yes. Friends, yes or no?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes. So I'm expecting you to open the second sheet, second SPSS file named as bank loan. Once you have opened it, please tell me so that we can proceed. Shall I proceed, friends?
Yes, yes, ma'am.
Yes, ma'am.
Fine. So I am on a variable view of this sheet. There you can find we are having so many different variables listed, right? So you need to pick any of the numeric variable from this. So if I will see, I am having the age variable, I am having the income variable, right? Then I am having the credit debt in the thousands, etc. So we are having various variables which are numeric in nature. So one of the variables we are selecting here to test the normality. Suppose I'm taking the income variable, and we will check whether the income is normally distributed or not. So using all the methods combinedly, I'll explain you how we can check whether this variable is normally distributed or not. So I hope everyone has opened it, and I think I decided we'll go for the income. Now, the first step is you need to go to the analyze, go to the descriptive statistics, and click on explore. So please see, go to the analyze menu, select descriptive statistics, and then select explore. Then done, everyone?
Yes, ma'am. Yes, ma'am.
Okay. If you have selected this, click on this. Once you will click on this, explore box will open. From there, you need to select the income variable named as household income in thousands. Select this and shift it into the dependent list box. Done, everyone?
Excuse me, ma'am. What is the factor list? What does it mean?
I think that I'll explain you in the upcoming days, ma'am. Right now,
Okay,
you
okay.
can use this.
Okay.
Yeah. Selected and shifted the variable. I hope everyone. May I proceed?
Yes, ma'am.
Okay.
Yes,
Click on the statistics button. You need to only cross check that descriptive should be checked. Then click continue. Go to the plots tab. In this tab, what is the by default option of the box plot? We will go with this. We are not making any changes here. At the right side, under the descriptive, deselect stem and leaf and select histogram. Done. And then from the next, you need to select the normality plots with tests. So these are the two check boxes we need to check. and we are deselecting the stem and leaf because this is a very older method. Nowadays, no one is using this. So we'll go with histogram and normality plots with tests. Done, everyone? Yes, shall I proceed? Yes, friends.
Yes, ma'am.
Okay, click on continue and then okay. So once you are doing okay, I hope you got the output in your output viewer. Done?
Yes.
Now the first section, which is the case processing summary, you can find we are having total 850 observations and nothing is the missing value. So the total is coming as 850, right? This is the first table. Next table is the descriptive table. This is a first time I'm explaining you, so listen it very carefully. In this particular table, household income in thousands is listed here. Means for this variable, we are getting the descriptive statistics. So the mean household income is 46.6753. This is the mean household income. 95% confidence interval for mean. So the lower bound is 44.0805. Upper bound is 49.2701. So in this particular meaning of this particular thing is that if you are picking any other sample from the same population, so the chances of falling mean or the mean will be coming in this particular range, right? So 95% chances that mean will fall in the range 44.08 to 49.27. Is it clear, everyone? Or do I need to repeat?
Ma'am, please repeat.
Okay, I said if we are taking another sample from the same population, so the chances of falling the mean of that sample, 95% will be chances that the mean will fall in the range of 44.08 to 49.27, right? Means there is a population, one sample we have taken, using that sample we have calculated this. Now, if from the same population we are picking the other sample, right? So 95% chances are there that the mean of that sample, means mean of that particular sample income, will be falling in this particular range. So the chances are 95%. Is it clear?
Yes, ma'am. Thank you.
Yeah. Next comes 5% trimmed mean. 5% trimmed mean is that you are removing 5% of the observations from both the sides. In the arranged data, 5% from the both the sides you are removing, and that way this is giving you the mean. This is the trimmed mean, 41.5157, right? So it is indicating original mean is 46, and after the trimming the mean is coming this. That means there are outliers in the data because there is a large gap, right? So that means it is an indication there are certain outliers in your data. Next is median of the household income is 35. That means what? Meaning is very simple, that the 50% of the people is having the income below to 35,000 and 50% of the people are having income above the 35,000, right? Variance in the income is 1485.567. Standard deviation in the income is 38.54305. Minimum income is 13,000 and maximum income is 4,46,000. Range in the income is 433. That is, range is nothing but a difference of maximum and minimum. That is 446 minus 13 is giving you 433. Interquartile range is 32. Interquartile range is what? That is the what I can say, the difference of third quartile and first quartile is known as interquartile range, right? It is 32. Skewness of your data, income data is 3.701 and the kurtosis is 22.486. If you can recall the threshold, I told you skewness should be 0. You can find it is 3, right? So it is positive, means your data is positively skewed. kurtosis should be 3. So it is not 3. It is greater than 3. That means your data is leptokurtic data. It is clear?
Yes, ma'am.
Next is the tests of normality. Here you can check. Significance value, we will check for the Shapiro-Wilks test. Generally, when the sample size is smaller, we'll go for the Shapiro-Wilks test and not for the Kolmogorov-Smirnov test. So here we will report Shapiro-Wilks test. And if you will look at the Shapiro-Wilks test, the significant value is 0.000. I think as in this particular FTP, this is the first time I'm telling you the significant value. So significant value meaning is the P value. We need to compare this P value with the level of significance. So generally, we are testing or we are keeping the level of significance as 5%, right? So wherever the significance value is coming, that means always you are having one hypothesis. So if you are making your notes, you can write in your notes for the Shapiro-Wilks test, the null hypothesis is variable is normally distributed. I'm repeating, if you are writing, you can write H0 or H0. Variable is normally distributed. This is our null hypothesis of a Shapiro-Wilks test. I hope you have written. Yes.
Yes, ma'am. Ma'am, ma'am, I have a question here.
Hmm.
Ma'am, just wanted to understand that do we actually create a hypothesis to test normality of a data?
Yeah, if we are using test of normality, so we need to.
Okay. And is it recommended that we, whenever the data is quantitative and the research is quantitative, we produce this particular table in our research and report?
Ma'am, totally depending in which journal you are reporting. Generally, this is a notion of, or what I can say in statistics, when the sample size is 30 and above, generally we are assuming your data is normally distributed. So many times people are not testing it. So up to you in which way you are writing a paper, to in which journal you are submitting your work, whether the journals are asking for these things. So you can check the past papers published in the journals, and that way you can take your own call. But here, being a facilitator of this FTP, as we have decided we are going to discuss normality and the reliability, I told you how you can test, what are the ways of testing it.
Okay, ma'am. Thank you.
Thank you, ma'am. So if you have written your null hypothesis, now you can check the significant value is 0.000, which is less than 0.05. So as per the thumb rule, when your P value or your significant value is less than level of significance, in that case, you are going to reject the null hypothesis, right? We are not holding the null hypothesis. So we can say, in our case, we are rejecting the null hypothesis. So if we are rejecting the null hypothesis, meaning is that we are saying that the variable is not normally distributed. And if you can recall, looking at skewness and kurtosis also, we have commented the same. And if we will compare the mean and the median, in that case also we can find there is a difference. These two are not equal. So that means there is a problem with the normality of our income variable. Is it clear?
Yes, ma'am.
Right. So these were the numerical methods which we have talked about. Now we are going to the graphical methods. If you can see your histogram of the income variable, you can easily see the right tail is very large, right, in compared to the left tail. That means there are so many people who are drawing the highest salary, but they are very less in number. The bars are very small, right? Now, if I will look, because from the bare eyes, we can say that the income variable is positively skewed, right? Now, if you want to keep a bell-shaped curve on this, you need to double click on this. Once you will double click on this, a chart editor dialog box will appear for you. There you can find the bottom ribbon is available. There you can find there are various graphs available, right? So the second last is the indication of the bell-shaped curve. You can keep your mouse here. It is showing you show distribution curve. You can click on this. Once you are clicking on this, a properties dialog box will appear. which is indicating by default normal distribution curve is selected. You can close this window and then you can close your chart editor also. You can see the bell-shaped curve is coming on your output viewer above your histogram. Visible, I hope, to everyone, and simple to keep, right?
Yes.
Right. So you can check this is not normally distributed. When we are talking about the income according to the histogram also, there is a problem, right? Going down, now QQ plot. You can check your QQ plot is, as you can find your curve is going at the right side of your this fitted line. So it is indication your income variable is rightly skewed, positively skewed, right? Next is the detrended normal QQ plot. This is we not reporting anyway, so you can drop this. Come last, come to the end, and you can find we are having the box plot. Looking at the box plot, as I told you, middle line is the median value of your data. This is the upper line of your box, which is the Q3. This is the Q1, right? That is quartile 1, quartile 3. In this, this is the lower whisker. Below the lower whisker, you can see we are not having any circles or not any asterisks are coming. That means at the left side, there is no outlier available. But going to the above, that is upper side, if you will go, right side you will go, you can find there are certain circles, right? And beyond that, there are certain asterisks. So usually in this SPSS, if circles are coming as an outlier, these are known as insignificant outliers, right? And the asterisks are known as the significant outliers. Meaning is that if you are having insignificant outliers, it will not impact your result that much. But the significant outliers will definitely impact the results, right? So you need to take a call whether you want to drop them or not, or if you're dropping, up to what extent you're dropping them, right? So this way box plot can help you to analyze or to understand how many outliers are available in your data. Clear to everyone?
Yes, ma'am.
Right.
Yes.
Right. So this, yeah. So this way, this is the way of checking the normality of the data. So I hope it is clear to everyone. May I go for summarization of today's session?
Yes, ma'am.
Yes, ma'am.
Thank you, ma'am. So friends, if it is clear, I'll take, if you're having any queries, I'll take after the conclusion of the session. So if I want to conclude today's session, in the session today, we have discussed two concepts, the reliability concept and the normality concept. I told you that when we talk about the reliability, here we are testing the reliability of the entire scale, which is solely measuring a single thing. Means your question should be dedicated to the one construct, right? All the items of a scale should be keeping those things. Or if you are having some other thing, you can drop them. You can only consider those questions which are totally measuring a particular construct, right? So that way you can check the reliability. So we discussed reliability is nothing but we want to test the consistency of the scale. Means if you will conduct a same scale on this other sample, whether you will get the same results or not. This is what we are testing using the reliability, right? Then we have seen whether we are having the Likert scale data or dichotomous scale data. Usually for both kind of data, we can check the reliability. But majorly we are testing reliability for the Likert scale data. Then I told you, if you are having your own scale or you are using the scales of others, even in both the cases, you need to check the reliability. In case of others, generally taste preferences, things are getting changed over a period of time. So it is generally suggested if you are using the others scale, in that case also you can check the reliability of your scale, right? Then we have seen there are various methods like test, retest reliability, parallel forms reliability, then split half, and the internal consistency. And one by one, looking using the diagrams, I explained you what is the meaning of all the different types of reliability, right? Lastly, I told you that most important or mostly used method is the internal consistency reliability. So in case of internal consistency reliability, we are using the Cronbach's alpha, right? And then I told you Cronbach alpha threshold value is generally 0.7 and above. So in between 0.7 to 0.9 is accepted. If it is greater than 0.9, that means there is a multi-collinearity problem. And that means you need to check which items of your scale are very, very similar, right? Similar meaning is if they are highly correlated, that means they are identical to each other, and the respondents are unable to discriminate between these two items. So they are not differentiating your items. That is why you are getting the high correlation value, right? So this is the thing which what we have seen. Then I think I explained you how to improve convex alpha. There are three methods I explain you. First one is the observation method. That means you can read your own questionnaire and you can see if there is any redundancy. That means any repetition in the items or not. Or maybe you can check ambiguity also in the items. If you're unable to do so, you can take the help of experts of the field, right? And that way you can improve this. Next thing is you need to check missing values on a particular item. If any item is having so many missing values, either you can drop that item or maybe you can impute the missing value. Next one is the item total correlation. So the check I have told you, you need to check firstly for any of the items. If item total correlation value is negative, you will immediately drop that particular item if your convex alpha is not coming in a acceptable range, right? Then if it has improved, it is fine. If still there is some problem with the convex alpha, then you can go for choosing the very small figure, positive and small figure. For whatever item it is coming, you can then next drop that item. That way you can improve your convex alpha. There is no threshold how many items you need to drop, but you need to take a wise decision how many items you can drop from your scale, right? Depending which item is more important for you, whether you want to keep it or not. Then afterwards, I tried to explain you the process, and then we have moved to the second concept, which was the normality. So I explained you normality. Generally, we are testing for a numeric variable, right? And we have seen that normality are having certain characteristics like using the mean, standard deviation, skewness, and kurtosis value. We can ascertain normality of the data. I explained you there are methods like numerical and the graphical methods. In the numerical, skewness, kurtosis you can use. You can use Kolmogorov-Smirnov method, and you can use the Sapir-Whorf test. For last two tests, we are having the hypothesis. The hypothesis will be variable is normally distributed. Then I explained you there are graphical methods like histogram, QQ plot, and box plot. Using these methods, you can ascertain normality of the variable. Right? So friends, this was all from my side for the day. Now the platform is open for questions and answers. If you're having any question, you please ask.
Ma'am, you had mentioned that, can you please repeat, during the Cronbach's alpha test, you had mentioned that some variables can be rejected during null hypothesis. In that reliability test, you said that, but you have to give reasons. Can you please explain that?
I'm not getting your question, ma'am.
Ma'am, while explaining the Cronbach's alpha reliability test, you said that some variables can be excluded. In some case, I could not get that in the questionnaire and the test.
I clearly
but you have to
told
give
you
the
there are
reason.
three ways to improve your convex alpha. If it is not coming, if it is coming, okay, you do not need to drop anything, right?
If it is not coming, can you please explain that?
Right, explain the three methods. I think I revised. This I'm revising third time. You can please pay attention. I said three ways. First way, you can read your questionnaire very carefully. If there is any redundancy in the items, any repetition in the items, you can take a call which item you want to keep, right? Second thing, you can check ambiguity in the questions. If any question is which is double meaning, you are taking, suppose you have asked two people to read. One person is taking in other way, other person is taking in some other way. That means there is an ambiguity in the question. So you need to reframe that question, right? Second method, if after collecting the data, if you have found any for any particular variable or item, there is so many missing values are available, right? So you can drop that item or you can impute the missing value. Third way is the item total correlation, which I have already told you in the output of the Cronbach's alpha, that is the scale reliability output, you will get the item total correlation, right? There you need to check for any of the items, item total quotient is negative, you can drop that item, right? And if suppose all of the item total quotient are positive, in that case, still there is a problem with the Cronbach's alpha. So you can take a call, whatever is the very least value of your item total correlation, that item you can drop, right? So that way, up to 0.2 means for any of the item, any of the question, if item total quotient is 0.2 or below that, you can drop that particular item. And you can mention this thing for improving the Cronbach's alpha, the item total quotient you have checked, and for these number of items, the item total quotient was below 0.2 or maybe negative. So that is why you have taken a call to drop.
Okay, thank you, ma'am.
Fine. Any other query?
Thank you for your presentation, madam. Madam, I couldn't able to join in the WhatsApp group, madam. If I click that link, I'm getting error.
I think, sir, you need to request to the team RFI. Yogi, sir, are you there? Sir, can you please share the WhatsApp group link? Yeah.
Thank you, ma'am.
Thank you, sir. Yeah. Any other query? Fine. So if no queries, I think we can call off the meeting for the day. We can meet tomorrow and we'll discuss the next concept. Fine, everyone?
Yes, ma'am.
Thank you.
Yes, ma'am.
Yeah, thank you, everyone. Good night. We are meeting tomorrow.
Thank you, ma'am.
Thank you so much, ma'am. Yogi sir, I think we can close the meeting for the day. We can wind up. Thank you, sir. Thank you.